All right, let's talk about NVIDIA. For what feels like forever now, they've been the absolute, undisputed king of the entire AI revolution. I mean, their GPUs are the engines behind pretty much everything, right? From ChatGPT to all those crazy image generators. But there's a fundamental threat bubbling up, and what's wild is that it's not coming from some rival company. It's coming from inside the kingdom itself. So to really get what's going on, you gotta frame this the right way. Picture NVIDIA as this all-powerful king, sitting on a massive throne built of pure silicon. Their reign has been absolute, but now their most important subjects, their biggest customers, are starting to forge their own weapons. They're challenging the king's authority. And this is the story of that rebellion. So, how in the world did NVIDIA build this massive empire in the first place? Well, the answer is pretty simple: speed. Just a relentless, almost dizzying pace of innovation that has kept them light years ahead of literally everyone else. They're not just improving their chips year after year, they are completely redefining what's even possible. And this is where it gets kind of crazy. Just look at this roadmap. You've got the Hopper architecture in 2023. Blackwell is coming in 2025. But they've already announced Rubin for 2026 and even Feynman for 2028. This isn't just a product release schedule, it's a strategic message. They're basically shouting, go ahead, try and catch us. They are in a constant, all-out sprint to out-innovate everybody, including themselves. But here's the twist in the story. The very thing that made NVIDIA so powerful, the fact that their GPUs can do anything, is now becoming their greatest weakness. There's a hidden flaw in the king's crown, and you better believe their biggest customers are starting to figure out how to exploit it. This quote just nails the whole conflict perfectly. NVIDIA's GPUs are incredible pieces of engineering because they can do almost anything you throw at them. AI, high-end gaming, scientific computing, you name it. They really are the Swiss Army knife of computing. But what if you only need to do one thing, over and over and over again, billions of times a day? Well, then you don't need a Swiss Army knife. You need a scalpel. And this just lays it out perfectly. On the left, you've got the GPU. It's flexible, it's all-purpose, it's built for general computing. But on the right, you have the scalpel. That's an ASIC, which stands for Application-Specific Integrated Circuit. It's designed to do one single thing. But man, it does that one thing with insane hyper-efficiency. It's not flexible at all, but for its one job, it's unbeatable. So this all comes down to a crucial idea called the flexibility tax. Think about it. Because a GPU has to be ready to do anything, like ray tracing in a video game 1 minute and complex AI math the next, a big chunk of its silicon isn't actually being used for your specific AI task. All that extra circuitry costs money, it takes up physical space on the chip, and, this is the big one, it burns a ton of power. That's the tax. That's the price you pay for all that flexibility. And this is exactly where the rebellion kicks off. The biggest names in tech, who happen to be NVIDIA's biggest customers, have decided they're just done paying this tax. They've realized that for their huge, standardized AI workloads, they don't need a Swiss Army knife anymore. So what are they doing? They're forging their own scalpels. And we're not talking about a small challenge here. Look at this list. Google has its TPU. Amazon has Inferentia and Trainium. Microsoft is building Maya. Meta has its MTIA. These are not small startups, okay? These are the hyperscalers, the giants of the cloud. And they are all pouring billions of dollars into building their own custom AI chips, designed perfectly for their own needs. They're quietly building the arsenal they need to stop renting GPUs. And why are they doing it? Well, the numbers are just staggering. A dedicated ASIC, a scalpel, can be anywhere from 10 to 100 times more efficient than a general-purpose GPU for a specific job. We're talking about performance per watt here. And when you're operating at the insane scale of a Google or an Amazon, that's not just a minor improvement. That is a complete economic game changer. And that massive efficiency gain leads us to the real battlefield. Because this whole war isn't just about who can make the cheapest silicon. No, it's about something way more fundamental: energy. The raw amount of power needed to run this AI revolution is quickly becoming the single biggest thing holding it back. This chart tells the whole story. The initial cost of the chips themselves, the capital expense, or CapEx, is huge, no question. But look at the cost to power and cool those chips over their lifespan, the operating expense, or OPEX. It absolutely dwarfs the initial price tag. The electric bill is the real monster here. So if you can get the same AI result for a fraction of the power, you have an unbeatable economic advantage.
And this, right here, gets to the absolute heart of the matter. We're already hearing warnings that new AI data centers could literally outgrow the capacity of our electrical grids. So the real bottleneck on AI's future might not be how many chips we can make or how much money we can raise. It might just be the raw availability of power, of gigawatts.
But listen, NVIDIA is no passive king just waiting to be overthrown. Oh no. They see this threat with crystal clear vision, and they have launched a massive, multi-front counterattack to defend their kingdom and hold on to their crown. So let's break down their three-pronged defense. First, they're hitting the accelerator on innovation, just like we saw in that crazy roadmap. They're trying to stay so far ahead on raw performance that the efficiency gap doesn't matter as much. Second, they're moving into what's called vertical integration. And third, they are doubling, even tripling down on their software ecosystem, CUDA, to make switching away from them painfully difficult and expensive. Now, this second point is absolutely crucial. What is an AI factory? Well, it means NVIDIA isn't just selling you a graphics card anymore. They are selling you the entire system. Pre-built server racks with their GPUs, their CPUs, their high-speed networking, and the whole software stack to make it all run seamlessly. By controlling the whole factory, they make it way harder for a customer to just swap in a competitor's more efficient scalpel for one part of the assembly line. It's a brilliant defensive move. Okay, so where is all this heading? What does the future look like? Well, it seems like we're headed for a future where the kingdom of AI compute actually splits into two very different territories, each ruled by a different type of chip. And this is probably the most likely outcome. The market splits in two. On one side, you have training and research. That's the process of teaching a new AI model, which is messy and unpredictable and demands maximum flexibility. That is NVIDIA's absolute stronghold. But on the other side, you have inference. That's using the already trained model to get answers over and over again. And that process demands ruthless efficiency, which is where those specialized ASICs have a massive advantage.
And this gets us to some of the harshest economic truths about AI. As expensive as it is, training a model is a cost center. You don't make money building the model. It's like building the factory. The money comes from what the factory produces. And inference, the act of using the model, is quickly becoming a low-margin commodity. The real value, the real money, is in actually integrating all these AI tools into a real product or business workflow. And this right here is the core threat to NVIDIA's universal reign. As the AI industry matures, as the jobs we ask AI to do become more standardized and predictable, the need for that flexible Swiss Army knife starts to shrink. When the job is known, when it's repeatable, the specialized, hyper-efficient scalpel will always win on cost. Predictability is the ultimate enemy of the GPU's value.
So we end with this question. As AI continues to evolve, will its future be ruled by one flexible, all-powerful king? Or will the kingdom break apart, giving rise to a whole army of hyper-efficient specialists, each one dominating their own small but very profitable piece of the empire? The battle for the throne is really just getting started.